Awesome, Aaron. Thank you so much for the time, and really excited to partner with Carasoft here on presenting this, and also excited to have Carmelo and Eddie here from Vast. They're obviously working deeply with us as well as with Carasoft, so it's been a great partnership and one where we'd like to extend further to what we believe is a pretty significant paradigm shift in how to think about managing and analyzing cybersecurity data. So we'll do a few things. One, we'll cover who Dremio is. We'll cover Carmelo tag team with me, and he'll cover Avast a bit. We'll cover a bit about what's happening with Zero Trust and the mandates that are coming down associated with that. And then really the challenges we see going forward across both managing data and analyzing it, but also doing so cost effectively and with the myriad of tools you likely already have from a security standpoint and cyber standpoint. And of course, I'm excited also to show you Eddie's demo, which I think will convey really the power of the solution in a pretty quick, slick way. With that, let's jump in, talk about Dremio. So just context for you all, I joined Dremio from Splunk actually, and a lot of you know Splunk. I ran both the product organization as well as the cloud business there. And certainly I'm very empathetic to the life of a cybersecurity professional. I know the sort of toil it goes through in terms of the amount of forensic work you have to do, the IOC work you have to do, always managing the myriad of tools. And of course, in doing so, also ultimately delivering what you're looking to do every day, which is identify those bad actors and remove them from your environment, which of course is paramount. Now, with that in mind, one of the beauties of that history is that now with Dremio, we're able to bring what we believe is the next generation Lakehouse architecture approach to cybersecurity professionals. So what does Lakehouse mean? Lakehouse means it's a combination of both a data lake, so the sort of cost performance benefits we all got from a data lake, but also the full richness of data warehousing capabilities and the analytical power that comes along with that. That combination is what we call a Lakehouse, and that is what really makes and enables a sea change in terms of how you manage and analyze cybersecurity data. Quick three things to know about Dremio. Number one, we are built on open standards, Apache Arrow, Apache Parquet, Apache Iceberg, etc. Number two, we are really optimized for world-class analytical performance. So for us, whether you think about needle in the haystack analysis of forensic information or having aggregates and analytics for IOC-based data, all of those things are really powered through Dremio's SQL engine. And because we speak SQL, we're able to talk to really any analytical system, including cybersecurity tools, SIM, SOAR, et cetera. And then finally, I'll say, doing this across a global 2,000 customer base, you can see a lot of the logos on the page there, not only commercial companies, but also, frankly, a fair number of federal agencies as well, running us at massive scale on millions of queries. So we certainly can solve large problems for customers, but it doesn't work without a partner that can deliver a data-centric and AI-centric platform. And that's why we've partnered deeply with Vast, and we're excited to be working together. With that, let me hand it over to Carmelo to give a quick overview of Vast.
Thank you very much, Sendur. When you think about Vast, we were born back in 2016, and our real goal is to solve data challenges. And we brought to market a capability called DAYS, disaggregated shared everything. And to be able to do that, you have to separate state from compute. And because of that, we've grown immensely over the last 8 to 9 years. We partner heavily with Dremio around analytics in general. And when you look at the cyber side of the conversation, what was really interesting about Vast is last year we introduced our data warehouse capability that was optimized for high throughput ingest or inserts. And because of that, had a little kink there. We've been growing very, very quickly in the cyberspace. We partner with a lot of different companies because you can find Vast in the cloud and on-prem. We run on a lot of different hardware providers, whether it be HPE, Dell, Lenovo, et cetera. We have an immense amount of customers in the Fortune 50, 100, and 500 area that leverage us for many different challenges, whether it's AI, ML related, or big data related, or analytically focused. With that, we've been powering cloud providers as well. So now you'll find companies like CoreWeave and Core42 where they're native data capabilities are powered by Vast and offered to their customers who consume cloud resources out of those environments. We've also been evaluated by Gartner Peer Insights for the last 4 years and have always come out with 100% grade. We're in the Magic Quadrant underneath the Challengers section today, hopefully Leaders tomorrow. And with that, I'm going to hand it back to Sendur to talk more about ZTA. And then I'm going to jump in and talk about the pillar we're focused in on today.
Great, thank you. Well, of course, the paradigm of zero trust has so many pillars. What we're going to focus on today is primarily around visibility and analytics. Zero trust is sort of an all-encompassing term, but certainly in the context of visibility and analytics, there are very specific requirements as it relates to collecting data off items off the network and being able to really apply a zero trust approach to your IOC and your forensic work, whether at the endpoints, firewall, switches, applications, whatever that might be. And one of the things that I think you'll find about the solution we're going to talk about today, but frankly, the reality that you face is that you live in a hybrid world. You've got analytics, you've got work data centricity happening in multiple cloud providers, likely Azure, AWS, GCP, at various gov cloud environments, et cetera. And you've also got data sitting in an on-premises private data center. The last thing you want is to shift that data back and forth across all those areas. That doesn't make logical sense. You're simply copying data and you're simply wasting all those compute dollars and revenue dollars. But we believe that kind of a really different approach can be done as it relates to applying zero trust capabilities specifically in the visibility and analytics area, which we're going to talk about a fair bit. Now, certainly that's one pillar, but we should think about how that can then be applied to things like orchestration as well as data as well. So it's not a standalone pillar. It plugs into, frankly, all the other zero trust elements that come into play. But I know there's a lot of noise recently about the mandate. And so with that, let me hand it back to Carmelo to talk a bit about the mandate.
Thank you, Sendur. The other thing that's been really interesting is the M2131 retention mandate. All federal agencies have to retain all the syslog and event data, all the PCAP data for these set time periods. And because of ZTA, you're collecting more cyber data from more devices than you ever have in the past. And now you have to retain that data for a much longer period of time than you ever have in the past. Hot data has to live for 12 months. They call it active storage. Most people correlate this directly to flash storage, whether it be in the cloud or on-prem. And then when data becomes cold, you have to hold it in an archive, or also known as cold storage, for another 6 months. With that, you also have to retain your PCAP data for 72 hours, which most people have not done in the past. And to give you an example of why I'm bringing this up, if you have a 100 gigabit span port that's fully utilized and you collect 72 hours of PCAP or packet capture data from that span port, you are looking at over 3 petabytes of data stored, whether it's unstructured or structured, depending on how you ingest that data. And if you have multiple taps throughout your environment that integrate with your TICs so you can get out to the internet, that creates data sets that you've never had to manage prior. And how are you going to solve that? Along with that, if you just look at storage alone and you only kept data for, let's say, 30 days to get to 18 months, that's an 18x increase that no one planned for, that just came out in the mandate. And the mandate also didn't come with associated dollars. So everybody can say, oh, I got something I got to do. Here's all this revenue or all these dollars to solve the problem. Now you have to look at the solutions you have and what is the best approach to meet the mandate's requirements. And then when you peel the onion back on the mandate, there are different levels that every agency has to achieve. The mandate's been out there for, what is going to be 3 years now. And by the end of 2025, everybody has to be at ELI 3 or level 3 from a collection perspective. And there's some predefined elements in the mandate on what you collect, how often you have to collect it, and then the structure of that data that not everybody has the tools in-house today to meet. So just something to think about when you look at this mandate. And the other thing we've noticed is that agencies aren't getting waivers anymore for some of these requirements. So as we look into 25, people have to think differently about how they collect, manage, and store this data versus how they analyze it, and how they also do forensics against it. With that, I'm going to hand it back to Sendar, and we're going to start talking about some of the challenges we see when you look at ZTA, and also how you store the data that you have to collect because you're implementing a ZTA framework.
Okay, well, that's a good one. So I'll let folks jump in on the poll here. What are the challenges you are encountering as you comply to the mandate? So to the extent you can put, and it's a multiple choice, so feel free to drop in what you believe are the most near-term issues, whether it's cost, scaling, etc.
Yeah, so when you think about one of the challenges we've seen at Vast with Dremio as we engage with our customers, the hardest thing is how do I ingest all this data? It's coming from disparate data sources, whether they're in closets in a small location where you support employees, or they're in the cloud or something in the middle. And everybody's using a plethora of tools to solve this problem. You could have Confluent or Kafka. If you're a Splunk customer, you could be using universal forwarders and heavy forwarders. You could be using both together. It gets a little bit complicated, but you can do it. There are other companies out there that make the collection of data more streamlined, like Cribble, as an example. And then we're seeing everything in the middle from an open source perspective, where people are using Pulsar, Apache Kafka, instead of the supported version with Confluent. But the long and the short is it's very hard to solve this problem. And then as you collect that data, your ability to curate that data from all these formats and then normalize it and store it over time and still make it accessible for forensical analysis is very, very hard to do. Most companies have been challenged with moving from tape into online capacity, things like object stores or archives, or if they're in the cloud, they're leveraging S3 as an example. And they have to figure out, how do I get all the things I need to collect this data, store it in place or store it centrally, depending on how much you're collecting and what type of WAN you have implemented. And then how do you know that you're retaining it correctly? How are you doing lifecycle management? How do you know on the 18th month that, on the 31st day of that 18 month, all the data that needs to be purged is being purged as you're collecting more data? And these are the challenges we've noticed so far. And I'm going to hand it back to Sendur to talk about some of the analytical challenges and sharing challenges we've seen.
Yeah, I'll before I get into that, I'll tell you the volume of data you're talking about. I remember, my old adage at Splunk was, well, every indexer would be 300 gigabytes of daily ingest, 300 gigs. Like, that is nothing compared to the type of data volumes we're talking about here. So when you think about the way in which you want to ingest that volume of data and the way in which you want to store that data and analyze it, you have to think differently. I think it's just fundamentally a different approach. When you have 10x, 18x the volume of data, even if you throw more hardware at the problem and more budget at the problem, the physics just don't work. You got to shift the paradigm a little bit. And that's what I'm very excited about, what we can offer with the Cyber Lakehouse. I agree with the items that Carmelo said. I'll add a couple more as it relates to analysis and sharing. Coming from the security world, historically, every security solution would have a different way to analyze data. Splunk would have SPL, you'd have XDR with Palo Alto, with CrowdStrike, you'd have Cribble would have its own language, you'd have all these different pieces that connect together. But you know what happens? You're having to replicate data across all those data locations. I got to send data into Splunk, I've got to send data into CrowdStrike, I got to send data into all these solutions. Maybe I have a CSPM solution, I'm tying in cloud data as well. And so all these pieces need to now connect together. So what you really have is a challenge of now a myriad of tools, all of which are requiring multiple copies of data, all of which have different price performance dimensions. So really you need to think about a different way to approach a problem. How do you think about changing compute in a very different way? How do you do it once and not multiple times? How do you make sure you can accomplish both structured and unstructured data? Because frankly, engines are typically built for one or both, and one or the other historically, and that actually has changed from the evolution of the analytics engines we're going to talk about shortly. But also we're seeing multiple sources of truth. If you're sending data to lots of places, you have different sources of truth. So now the data analysis becomes more complex in a world where you have greater volumes of data, but also variety, with now more data coming in and more vendors in this model. So you need a more holistic way to approach it, analysis, we believe, going forward. And then of course with data sharing, when you send data into proprietary systems, as you change those systems or as you want to pull data out or run different analyses, the last thing you want to do is to have to copy in the cases that Carmelo said, petabytes of data to do a simple analysis. That makes no sense in the world. So you want to be able to access data to open standards-based models, NFS, SMB, S3 API-based approaches, which is what Vast can provide from a infrastructure standpoint, and of course, Dremio provides from a REST and API standpoint, REST and SQL standpoint. So now you get really a holistic way of looking at the data from raw all the way to curated in a way that is an open standard. That's our approach that we believe is important going forward. With that, let me just jump in with these challenges. Let me now double click a little bit about what we believe is the true cyber lakehouse going forward. I'll start, and certainly Carmelo will add in the next slide here. So we're very excited about what we believe can truly address this next generation of challenges. And as I said, this is really a paradigm shift. Now to think about storing and analyzing data. And this is our next generation cyber lakehouse, built on Vast as that AI data platform and Dremio as that data analytics solution. So this combination really gives you the ability to ingest at large scale, but through that all-flash architecture that the Vast provides, and of course priced at archive pricing. The second piece of this is, of course, ingesting at scale, which we talked about earlier. It's the other piece that the Vast can do, and I'm sure Carmelo will add in double clicks in a second. Of course, retaining data at large scale, also important. One of the things I love about Vast, frankly, is that we're able to leverage the fact that we don't need to tier data. Everything is hot tier. So the last thing you want to do as a security professional is to decide, oh, I only want to search 15 days of data. So I want to do hot in this bucket and this bucket. Like, why do you have to have, that's a false choice in my mind. You got to be able to look at the data. If you're storing all this data, there's a reason for that. You want to be able to run large scale forensic analysis, especially for long-term APTs. You want to make this easier for customers. You want to make this easier for users and your cybersecurity analysts. So that simplicity comes through with this architecture. You also want to have a scale out analytics model, because if you tie storage and compute together, those are two very different axes of operation. And so with this model, we're able to do scale out SQL-based forensics and security analytics, of course, leveraging cheap compute wherever you need it, and of course, providing that single source of truth. And of course, Dremio and Vast coming together with data sharing. And the beauty of this is it's not tied to any security solution. If today you're using Exabyte for SIM or XDR, and tomorrow you want to use Splunk and enterprise security there, great. You want to move from that to using CrowdStrike, great. We actually don't care. Why? Because our approach, the fundamental approach of this cyber lakehouse, is decoupling your data, your compute, your storage from the rest of the cybersecurity tools out there. Because as you know, those change constantly. Last thing you want to do is, if you're flipping cybersecurity solution, you're held hostage on data and compute sitting in one place. And you're also allowing that freedom to go and advance your AI and ML capabilities even faster by having an open access, even if any one single vendor does not have that capability today. So it's really changing the economics of storage. No more copies of data going to multiple systems. It's changing the economics of compute, both on the ingest piece with Vast and the analytical side with Dremio, right? You're able to maintain a single copy of data. You're able to maintain a single copy of aggregations and summaries, which then get exposed to lots of other systems. And you're changing the physics of access and auditing, because now you get that through one central platform. I'm sure Carmelo added a ton more from what I said. With that, let me hand it to Carmelo to talk a bit more about our cyber lakehouse.
Yeah, so the thing I was going to pull the thread on was ingestion. So if you heard earlier, we said that we had data warehousing capabilities. And if you've been around the SIM market for a long time, it started with using databases on the back end, and then they didn't scale, and people moved on to ELK stacks and using search engine-like approaches with Solar and Lucene to solve some of these problems, hence Elastic existing today as an example. What is really uniquely different here, and Sendur hit on it very early on, right? The ability to decouple compute from storage. Fundamentally, Vast is built on that model. It's what made us very unique when we started as a company. And because of that, we've decoupled the ability to, we decoupled the legacy approach of having to scale everything together and then not being able to manage it monolithically as you move forward. So one of the unique things around ingest is we leverage, when you look at the hardware we run in a data center or the hardware in a cloud we take advantage of with our software, we leverage storage class memory to act as our write buffer. And because of that, we can take event data ETL it in place, and then transform it into rows that land directly on storage class memory that scale out by node. So now I can scale out my ingest completely independent of the applications that are writing that data, whether it's coming from Kafka, whether it's coming from Splunk, whether it's coming from Cribble. We really just do not care at that point, because we can also speak to all those apps in a native way. As an example, with Splunk, you could use NFS. With Cribble, you could speak S3. With Kafka, you could literally just subscribe to topics because we have a plugin for it. As an example, we're very ubiquitous in that regard. And then once it lands in storage class memory, we have this ability to move it into columnar compression tables that are optimized for queries. And that is what makes us uniquely different here, because when we optimize the data as we lay it out on the flash, independent of where you run our software, tools like Dremio, specifically Dremio, because they have our plugin, they're the only game in town right now in this regard, which is a good thing for this solution. They get to query that data very quickly. And you'll notice I only said flash. We don't tier data. Between the combination of storage class memory and QLC NAND, and the fact we can columnar compress and dedupe this data, we found a way to give you S3-like archive pricing for data warehouse-like scale and analytical purpose and performance. And that is very, very unique to Vast and Dremio together. I've honestly never seen a solution like this prior from a single vendor. I don't know that you could get there, but taking the best of both worlds, the best execution engine in the business, and what I would argue the best data platform in the business, you get the industry's first scalable cyber lakehouse that can run on-prem in the cloud, or you can manage them together, because we do have hybrid capabilities where you can do federated queries and we can move tables to where the compute is with the vast data space, which is very, very unique here. And that keeps everything hot all the time, which checks the box for the mandate, whether it's cold or hot, but more importantly, makes everything available for forensical purposes from the day you get that data to the day you have to delete that data, which has never been done in the industry. I'll hand it back to you, Sendar. I don't know if you have any last words or if I should go to the next slide.
I think you hit on a lot of the important points, but I'd love to hear from the audience. Like, how many of you are looking or have implemented a Lakehouse environment? Do you have one? Do you plan on implementing one? Would love to understand that. Or if you're just sort of early on and thinking about this, which is totally fine as well. Would love to get some feedback from the audience. Okay, well, we'll get that feedback. Why don't we go to the next slide? And Carmelo, do you want to just walk through what I think is a great way to describe this? This is at a high level, but I think we can double click on the actual technicals. And one of the best ways to do that is through kind of looking at the actual life cycle of data, where it starts, where it ends up, how it's made available. And, before you jump in, what I will say is what I love about this is, again, paradigm shift in how you think about cyber data. Historically, the model was, I've got to put it into Splunk, or I've got to put it into Elastic, or I've got to put it into ArcSight or Exabyte or what have you. Now the benefit is, no, you get one copy of data. So whether Grafana looks at it, or Elastic, or Splunk, or what have you, they get a single source of data, which I think is really powerful for cyber analysts, because the last thing you want to do is move data. As well as I do, team, we've been there where we've got a tab open for Splunk to do forensic analysis, and you might be looking at a tab over here in Datadog or AWS, CloudWatch for something there, or Sentinel. You want to be able to bridge those worlds together as much as possible, and this allows that to happen in a decoupled way. With that, Carmelo, would love to have you walk through this sort of data lifecycle here.
Yeah, no problem. So we've noticed there's a lot of different things that create data you have to collect when you're implementing a ZTA-based framework. We've noticed that you have to do packet capture on all your spam ports that hit the internet. You got to know what's going on, especially for outbound and inbound traffic. We've also noticed that people love to collect NetFlow data and store it longer, because it's the information about the packets that's sometimes more important, actually most relevant when you're looking for something. This data can come from your firewalls, your switches. They can come from routers. It just kind of depends on how your network's configured. We've also noticed that there's a lot of exploits around DNS, man-in-the-middle exploits, things like that. So that data is becoming more and more important. You can actually see, when you have an abnormal amount of DNS traffic on a specific port, that is probably something's happening. As an example, that is not regular, because no one does a lot of lookups very quickly, but you can see exploits that way. The traditional syslog data set, which is really interesting here because when you're in the federal context, you have to apply what they call the STIG, which has 200 plus audit D controls that you now have to get all this extra data you didn't plan on if you had never touched a federal deployment prior. And then the other thing that's been really interesting is the M2131 mandate forces you to collect even informational events, not just critical events. So the volume of syslog data you have to collect now is increasing, 10x versus what you used to. And now you're collecting it from everything on the network, not just critical devices. And then lastly, your Ceph traffic. As all that data is collected, we've noticed a lot of different ways to collect that data. We've been partnering with Cribble and Confluent, or also known as Kafka, as ways to collect that data. A lot of SIMs have internal mechanisms, whether they're using heavy forwarders or universal forwarders like a Splunk. And then lastly, where customers are already at a certain volume, they've already went to the open source community and they're starting to use Apache Spark with Apache NiFi as another mechanism to collect that data, because the volumes they're hitting have broken all the COTS-based tools, and they're having to scale collection independently of how they analyze data. As that data is collected, we actually embedded Spark into our platform, and we have plugins for things that don't support Spark, so we can subscribe or consume all this data in its raw form and store it and curate it within the Vast database at scale. One thing to note about the database is our schemas are built to get to an exabyte, to have trillions and trillions and trillions of rows, tables, thousands of schemas deployed. So our ability to collect and store this data is second to none. From there, Dremio leverages a Vast plugin to make that data extensible, queryable, and analyzable from the Dremio framework. And then your SIMs, your SOARs, your XDRs, they leverage things like JWC, ODC, or Aeroflight to reach in through Dremio to get access to this data. The other thing that was really interesting or intriguing for me about the Dremio relationship for us, when you look at how data flows, is its ability to transform data on the fly as you're querying for it. And the reason why I bring that up is at Vast, we consume those messages in its native structure, and we store it into schema or into the schema associated to the data type. So whether it's PCAP data or syslog data, et cetera. At that point, there's a lot of capabilities in Dremio where you can remap that data and not have to go through an ETL function. And I'm going to hand it over to you, Sendur, to talk about some of those capabilities.
Oh, that's great. Let's jump in. So this one gets me super excited because it's, again, a paradigm shift. So we'll go to the next slide real quick. And in it, what we've done is just give you a simple layer cake diagram. We've got obviously Vast at the foundation, providing that raw event data as ingested at scale, as Carmelo mentioned, no data tiering, et cetera. So now it's open, available in an open standard model by the protocols we talked about earlier. Now, where does Dremio come in? Certainly, we do raw SQL-based analytics. So you write a SQL statement, you can certainly search any of the data that sits within Vast. And that combination of Vast and Dremio, we take advantage of each other's architectures to make sure that's really performant. And having, again, been at the days of Splunk where you have to do a large-scale IOC query, I can tell you it takes a long time. That is not the case with this solution. It is a fraction of the time. And Eddie will demo this in a moment here. But as you can see in the visual on the second box, we have Dremio sitting there, certainly being able to access raw data via SQL. But you'll notice some boxes on top. And these are OCSF, the Open Cybersecurity Schema Framework. And what that means is we can apply, and this is certainly this framework, but if you choose to use other schemas, totally fine. Maybe you have an agency-specific schema for a particular type of event data, for example, that maybe, I don't know, forward deployed items that may be more relevant in your space versus a more OCSF model. But irrespective, you can define these what we call virtual data sets within Dremio. And why are these virtual data sets important? One, those virtual data sets are truly virtual. You don't need to a priori summarize them if you don't want to. You can actually make them sort of virtually available. And when query time happens, we actually take a look at the query, analyze it, and take advantage of summaries that may or may not exist in the system. So why is the power of that so important? Historically, the world of querying something meant you have to know what table you're looking at, and you have to know what columns and queries to go exactly right to take advantage of that summary. One of the beauties of Dremio is that we have a capability called reflections. what does that do? Well, whatever the query that comes in, whether from SIM, SOAR, XDR, even custom application, we look at that, we actually do a query plan on that. And when we do that, we say, well, these queries can take advantage of these summaries over here. So imagine two different IOC queries on login activity. Say one comes from the SIM and one comes from SOAR, okay? Imagine both of them are written completely differently. They leverage the OCSF framework, but they're written differently. What we will do within Dremio is look at that query and say, hey, we could take advantage of a summary we have and automatically leverage that summary to accelerate performance. Why is that important? Well, it means you can decouple the security tool from the Cyber Lakehouse. So when that Cyber Lakehouse can take any SQL query and come in and say, I can replan the query and rewrite the query at runtime to take advantage of summaries, that's very powerful. And Eddie's going to talk briefly about how, or show truly in the code, how much more performant this can be. The other real benefit of this is it can be virtual, but you can also, through a click of a button, make it actually fully materialized. And why is that important? It means if you want to take advantage of, say, lower cost compute at nighttime, you want to take advantage of IOCs, you're always going to be searching more often, you can actually do that dynamically in the system as well, all through a self-service model without having to truly write as much SQL, which is really powerful. So you not only get this dynamic ability, which takes advantage of the OCSF, you can actually update it incrementally. Meaning one of the big elements about security data, as you all know, is it's event data, it's time-based data. So data comes in incrementally every minute, every hour. Most systems, Splunk included, other large analytical cyber-specific solutions would typically run the query over the full period of time. I'm running a 30-day IOC, to give you a very concrete example. I'm running a 30-day query on when did Carmelo log in? What IP addresses did he log in from? What geo address over the last 30 days? Imagine that was a IOC-specific structure that now, if you run that every time in one of these other solutions, you're repeating that query and you're analyzing and scanning all 30 days constantly. Every query, every time. But with Dremio, we actually summarize those into chunks. And because of that summarization, not only are you fast, you now no longer need to re-summarize constantly. You have to take advantage of the summaries. And when a new day comes on and an old day goes because it's a 30-day rolling window, we only incrementally process. So the benefit of that is that you're not having to do, you're not doing 1/30th of the compute you used to do before. It's pretty powerful in terms of how to take advantage of this. We believe this kind of model that fundamentally changes the paradigm of how to do compute and now storage and ingest with this combined solution truly changes the physics and economics of this model. And that's why we're so excited about this. And we think it'll be a real impact to how customers and agencies think about managing their cybersecurity data in a much more open and transparent way. And again, in a hybrid model, right? Because the last thing you want to do is take all your data on-prem and shove it to the cloud. You want to find that right balance across all that data. So excited about all this. I've got a couple more slides. And in fact, the next is going to be the demo. Before we do, I think we have a quick poll we're going to ask folks. Which tools are you looking to integrate with this data? Certainly you have SIM and SOAR, I imagine, maybe XDR as well, or others. We'd love to get a pullback from the audience of what tools you're looking to integrate. Okay, while that poll happens, Eddie, I'll hand it over to you to talk a bit about the actual demo. And we'll go to the slide and over to you, Eddie.
Thank you, Sendur. The demo that we're going to take a look at is the implementation of the Cyber Lakehouse here in an extremely convenient way where we're leveraging Splunk. So if you already have Splunk that you're using for cyber and other purposes, you can actually keep using it as your central place in order to run queries, all of your dashboards, all those other things, and transparently query into the large data store that is Vast through the power of Dremio and all the other goodness that it provides. So we're going to take a look at some specific examples. I'll give you a little bit of a taste of the different interfaces and what's going on. And without further ado, I will go ahead and share my screen. Okay, so what you're looking at right now is the Vast interface. So Vast manages all your storage. You can access it through a variety of ways. You can do all kinds of access controls. You can do federated data space management. And of course, the more structured data inside of Vast database, as you can see here. So we have a variety of data pre-ingested for the purposes of this demo, including net flows. So this is 60 days worth from a moderately busy, just one server. So this is 440 gigabytes. And this is just 60 days worth, and it's not even a very busy server. And so you can imagine how this can get out of control. as you're trying to meet all those mandates and maybe do some kind of network security monitoring program that really tries to take in, look as much data as possible. So with Vast, scale is no longer an issue. Your concerns for storage and compute are completely separate, so you can keep syncing data in at very high rates and basically not worry about it. So the NetFlow data in this particular demo, all of this is inside of Vast. And now I'm going to show you Dremio. So Dremio you can think of it as the one place to query all the data no matter where it resides. And this is more open-ended than just accessing data in Vast. It's accessing data in S3. Maybe you have Postgres. Maybe you have Microsoft SQL. Maybe you have CSV and JSON files just sitting on storage. All of those things can be accessed as make-believe databases, tables, etc., so forth, just using SQL. So I will show you here a very quick query. And as you can see, this is just vanilla SQL. So we're just going to select a number of rows from Vast database. And one thing I want to point out is there's autocomplete here, so it helps you quite a bit. All right, there's our packet data, headflow data. And we'll just grab 20 rows just for the sake of example. Go ahead and run this query. So pretty quick. This is actually from a smaller data set, just for the example purpose here. And now we can take a query like this, and we can actually run it from Splunk directly. So what do I mean by that? So let's go to Splunk. So here's the Splunk interface. I'm actually inside of a SQL Explorer view of the Splunk DB Connect plugin. So Splunk DB Connect provides JDBC and I believe ODBC connectivity to from inside of Splunk, and is managed, maintained, and created by the Splunk themselves. And one of the nice things about it is it also has the SQL Explorer functionality, and it helps you translate your SQL queries into the Splunk query language. So we're just going to select a Dremio connection, add this in, and as you can tell, the translation is quite straightforward, right? So you can run it here. It works. We're going to open it up and search. It works as well, right? So I'll pause here for a second to say this is very transparent to any other workflows that you have in Splunk. This is just Splunk query language. If you have dashboards, if you have other things, it just works, right? So it doesn't require you to do anything, but maybe instead of using queries that are non-SQL, you're now also mixing in SQL in order to access all the data that is inside of the data lakehouse. This does not increase your Splunk license cost. That does not increase the utilization on your Splunk cluster. It is extremely minimal from the Splunk perspective because all the actual queries are run on Dremio, and all the data is served from Vast. So one of the things that makes this extremely compelling, beyond the fact that you now don't have to inflate your Splunk deployment, is also the ability to change things on the fly that Sendur alluded to earlier. I want to show you the following visual. So here's an example of an out-of-the-box dashboard that is provided. I believe this one is provided by Splunk themselves. So it's from one of their blogs. You can load it in, and this is used in order to just display you interesting information from NetFlow data. So how does this actually work, right? So the way that things like this work is by conforming to certain conventions for how the data is structured, what the fields are named, and so on and so forth. So as you are trying to basically get the most out of the content that is out there, so the dashboards that maybe were created internally by you or externally by Splunk, other vendors, etc. One recurring thing that you're going to notice is they're usually following conventions for data naming, such as OCSF or Splunk's internal one. If you're using other SIEM products like Elastic, that would be something like ECS. And you might not be ingesting data with exactly those correct naming conventions. So let's say you started your data collection program because that is the priority to start collecting data ASAP, and then you found out that oh shucks, you have a petabyte of NetFlow data in, but now you need to actually change what the fields are named, and maybe you need to slightly change formatting on some of them. Are you going to have to reprocess all of that data? So that is an extremely scary prospect. So let's see what we might do. So Dremio, one of the great functionalities of Dremio is that you can completely abstract how the underlying data is represented. So the data has tables with certain column names, etc., and so forth. But what you can do is you can actually create views on top of this data. And in this particular example, just 1 second. Let's open this up. NetFlow. So in this particular example, what I've done is I went back to our NetFlow data, and I just created a view. And as you can see, this is just regular SQL. And all I'm doing is I'm just remapping these different fields that, in this case, I had them in ECS format. That's how they're in the database. And I'm translating them to the OCSF format. And that's all I need to do. So now if we go back to Splunk, that query we ran earlier was originally looking at the NetFlow data, and as you can see, the format here is ECS. Now I'm going to run the same query, but the difference is going to be, if you can notice, it's the same query, but now it's looking at our view. So it's no longer looking at the raw table, so to say, it's looking at the view. So I'm going to hit it again. And this time around, all of these actual field names obey the OCSF convention. So what does that mean in practice? What that means in practice is if you had dashboards like this or you're endeavoring to use them, you can now make them work without having to re-ETL your data or do anything weird and unnatural. So extremely powerful. But it gets better. And one of the bread and butter things to do for a cyber analyst threat hunter is to deploy lots of different alerts. So this is how XDR products work. Splunk, Elastic, and so forth perform their own alerting. And latency is a factor, as well as the ability to look at the past data in order to inform you about whether the current event is anomalous is also important. It's important to be able to run those things at lower latency because typically these are live checks, right? We're doing cybersecurity operations. We're trying to get alerted on what's happening, at least every 5-minute interval or so. So we cannot just afford to run extremely expensive queries over and over and over again, right? So how do we make these queries run faster, and how do we make these queries less expensive? So another thing I want you to show inside of Dremio is the reflection capability. So here's another view. And as you can see, this is a SQL query. And I'm going to run it just to show you what it runs like originally. So this is querying right now that 60-day, half a terabyte data set for just net flows from a single server. And it took us about 8 seconds, as you see. And what it does, it just looks at the amount of traffic in a net flow, summarizes the sum of all bytes transferred between one IP and another IP in the set time period. You might imagine adding additional fields in here, such as ports, in order to perform aggregations. Maybe you are trying to spot, for example, if somebody is using the DNS protocol in order to exfiltrate data or move laterally. So you would be highly disturbed to notice that there was a whole gigabyte worth of data transfer just due to DNS inside of your net flows, right? So this is this kind of bread and butter query that you would use inside of alerting for cyber purposes. And in this particular case, it took us 8 seconds. So what we're going to do right now is we're going to put this onto a Jetpack. So the reflection capability inside of Dremio does exactly that. Without going too deeply into what's happening, I'll just point out some key things. So there are raw reflections, which gives you much faster access to data, even if you don't have any specific opinion on how it should be queried. And there are also aggregation reflections that speed up those aggregations, so those sums, those groupings, etc. one thing Dremio does, especially with aggregation reflections, is it will look at the query that you're trying to use in a particular view, and it will give you some suggestions. So it greatly speeds up, gives you a boost to the ability to define these reflections. And so let's turn these on. It'll take a little bit. And the other extremely nice thing about these things is, as you define these reflections, you don't need to think of them as, oh, I am accelerating this particular view, right? You're not accelerating a view. You are just telling Dremio that, please accelerate queries that look like this. So what that means is, even if you define reflection on one view, any similar query or partially similar query will leverage those reflections in order to give you speedups. So let's see what kind of speedup we're gaining here. So I turned the reflections on. They processed very quickly. And what I'm going to do now, let's go back to our other view. Traffic stats. Run it again. As you can see, it took less than 1 second. So we went from 8 seconds to less than 1 second. Let's look a little bit deeper here. So this is from a previous run that I did this. And in one case, we have 8 seconds. What here was 7 seconds. And then in the second case, we have just a little bit north of 500 milliseconds. So this is speed up of 14x or so, right? So this is extremely powerful. Where you do need the speed, Dremio offers you the ability to really accelerate those queries. So whether you're doing BI, whether you're doing alerting, other things like that, it can really give you that missing performance, if you notice, while still being able to access a whole ton of data, petabytes of data at scale, without affecting any of your existing SIEM deployment, licensing, hardware, etc. So I hope you liked our demo here. And just to go over it again, Vast stores all the data. Vast is able to ingest a whole ton of it. You can scale compute separately from stores and not worry about it. Extremely great economics and built-in compression. Dremio gives you the ability to query anything and everything that you like, and then expose it to any tools that you're using in the way most appropriate to them, including changing the data formats on the fly. And finally, other tools that you might be using, such as Splunk, you might have a very easy way to tie all of this together, because you can actually query through Dremio into your data lake, and without having to use any extra things, your existing workflows, your dashboards, etc., they still work. So hopefully this is very compelling. Thank you.
Awesome. Thank you, Eddie. Super cool to see. And I think one of the nice parts about it is those queries can be run by all the various security tools out there, which makes it even that much more compelling for customers, and that efficiency comes in automatically. All right, well, we're probably almost out of time here. So Carmelo, do you want to help us wrap up here on this last Cyber Lakehouse solution slide?
Yeah, so we wanted to restate some of the challenges we noticed and had communicated in the beginning of this conference. Data ingestion. Vast is purpose-built to solve this problem, especially for data you wouldn't think could be stored in a structured manner. We're really, really good at that, and we leverage things like Spark, our plugins for Kafka, et cetera, to do those things very intelligently. We curate that data. We can store it anywhere. We make it available to any tool. We can retain that data over time. You can even set things like lifecycle policies on a bucket or something like that. If you needed to, that will delete the data automatically at the end of the retention schedule that you can configure on demand. Those are some of the things our platform does extremely well. I'm going to hand it back to you, Sendur, to cover the last two. Do it better than me.
Great. Well, very good. We talked a lot about these pieces on the analytical side, of course, through the capabilities like Reflections, we're providing performant access to data. Again, that access is across no matter the solution you use. If you have a small Splunk environment and you want to search large volumes of data, doable. When you have a small cloud environment, also doable, because again, you're pushing that query down to the platform to go make that happen. That analytics happens there, and all you get back are the results. So the real benefits of this next generation architectural approach can be applied. And what I love about this is, we all know change is hard, team. Change is hard. Change is especially hard when you have to retrain professionals. But the beauty of the solution is that you can still leverage all the same great security solutions you've used. Splunk, ArcSight, QRadar, Logarithm, if some of you use it, pick your solution. But as long as they're talking SQL, we're able to take advantage of that and provide the analytical power here. So that really paradigm shift means that you have a lot less change fatigue at the company. Your cyber professionals continue to use the same tools and solutions and all the dashboards and all the IOCs and alerts and everything they've done before. And over time, slowly rework those into the OCS framework, which we all want to do anyway. So it makes that all that much easier. So really in combination gives you a lot more power and freedom in the approach, in the architectural approach of managing and analyzing your cybersecurity data. So this is what we believe is that next generation cyber lakehouse approach. So with that, I think we're out on time. We got a few minutes left. We'll want to open it up for questions from the audience if they have any regarding our technical approach. I'll hand it back to you, Erin.
Wonderful. Thank you for that presentation, gentlemen. So I do have a couple of questions here for you. The first one is, what have you seen from customers trying to comply with this mandate?
Carmelo, you want to hit that one?
Yeah, so we've noticed two key things. The environments they have do not have the ability to store, collect all the data that is required. So most people are struggling to figure out how to be compliant and going for, UFR-like requests to hope that they can do some type of Band-Aid approach for a data set, not all the data sets required. The other thing that we've noticed as they've tried to comply is that they're not thinking about the ability to forensically analyze the data over time. And they're just, I've got so many dollars, there's not a lot of it. I'm going to buy the cheapest, slowest thing I can get just to say I store the data. And then when that data becomes important to them, they won't have a way to analyze it. And that's been the two greatest challenges we've noticed, is the ability to store the data, and then secondarily, the ability to analyze that data.
Great, thank you. I have one more question for you all. It is, there are a myriad of tools in cyber. Is this a mechanism to keep it all together, so to speak?
I think it is. Certainly it's an approach to keeping things together. We also know, and I think Eddie touched on this very briefly, that we expect you're going to have some sort, as I always say, like data has physics. There's certain physics to data. It has weight because of the volume of data, the generation, the curation, etc. And so most customers tend to keep data in a hybrid model. They've got data sitting in an S3 bucket, or they want to use Vast in the cloud and use Vast. And we'd love that to be the optimal solution. And the beauty of that is we can federate the query across those environments. Often also customers will have lookup tables in, say, some proprietary database as well. They might say I have a Postgres database with information on Carmelo's address, for example. The last thing you want to do is put PII into your cybersecurity data. Well, imagine being able to get that at the time of query by federating that query out to something like Postgres and keeping that summary in Postgres in a more secure environment, but then pulling it into your query at query time, take advantage of that. We believe, while it is a approach where more data can sit in that lakehouse, and it is a lakehouse-centric approach to the model, we do believe that you'll have 5, 10, 15% of data sitting outside of the lakehouse that we'll want to analyze in real time for PII and other levels of security. That certainly will be the case, and want to make this a little bit easier. So Dremio will connect that with all the power that we already have in the cyber lakehouse capabilities.
To piggyback on what Sendur said, one of the things regarding the sprawl of cyber tools is different things just monitor different things. The data resides in different places. Now, Dremio gives you access to all of this as a single place. One thing that you would have never dreamt of doing in a conventional architecture is doing joins across this data live in order to, for example, give you much richer context to do alerting on, or BI on, or other things. And this is fundamentally the game changer that we're talking about. The conventional workflow of a cyber threat analyst is to go look at one piece, look at the next piece after that, the third piece, the fourth piece. Joins simply do not work at scale in something like Splunk or Elastic. They're not built for it, right? But this is a fundamentally different solution. It gives you all the goodness of the analytics as well as joins.
And one, not to add on, but, gotta say something. Now, one of the interesting things is when you do start to collect these join statements and those outcomes become very important, you can store those as a new table within the existing schema or a new schema on Vast. And what gets really interesting here is we have this ability via an API to turn that data out in other formats as a bulk export. And one that comes to mind is Parquet, because now I can turn out all this data in Parquet, and I could use a framework from NVIDIA called Dahlia. and I could load that data directly into GPU memory and train on it with an LLM and start interrogating that data and asking it questions. You've never been able to do that before, and that is something very, very unique to this joint solution. We have a way to visualize the data. We have a way to normalize the data based off the tool in an on-demand way instead of through ETL and reprocessing. We can store that data very easily and in a performant manner. And lastly, we can enable you to bolt on AI ML capabilities that you've never had before. And the world's going that way. And we're seeing this unique convergence between cyber and AI ML to speed up the analyzation and forensical component of what your everyday life looks like as an analyst. And that is very, very unique, because I see a world where 6 months from now, I have a chatbot that looks at all these independent data sources, and I could ask it every place Carmelo went on the network, every file Carmelo accessed on the network, and it will just give me an accurate answer. Not that that's a dream, because it's not. Me and Eddie are going to go build this next, now that we have a Lakehouse, and you can build that too in your own environment.
Very cool. And next time I'm going to refer to myself as a third person too, Carmelo. It'd be good. I love it. Very good. All right, everybody. Well, thank you so much for the time today. Hopefully you found this useful. Certainly reach out to the Carahsoft team to better understand how this might be applicable to your world. If you're consuming large volumes of cyber data, we will be highly relevant and likely provide you in a model that is far more performant and a fraction of the cost of your current solutions. Looking forward to chatting. Thanks, everybody.
Thank you.